I'm working at Google. I used to be part of nice, amazing Wear OS team doing Compose for Wear OS, and now I moved to something else inside of Google. But I was the primary point of contact for TransformingLazyColumn. And where do you find, and that is a new foundational list component on Wear OS Compose. And where do you find one? If you have Wear OS watches, it's pretty much everywhere. It is inside of notifications. It is used all around the SysUI in all sorts of launchers. And for that simple launcher, you think, yes, of course, yes, that's sort of a list. And until you go to the different kind of launcher and find it is being used in a grid view as well. We don't have a lazy grid component, but TransformingLazyColumn was done in a such way so that you can tune in some effects. And just to point out, when the items go to the top or the edge of the screen or any edge of the screen, they kind of start arching. And you can achieve all sorts of that stuff using TransformingLazyColumn. And QSS is TransformingLazyColumn as well. Not everything in Wear Compose is TransformingLazyColumn, but it was adopted nearly by all of the 1P apps. Here you can see the brand new weather app. Before TransformingLazyColumn, we used to have a ScalingLazyColumn, and the ScalingLazyColumn was implementing Wear Material 2.5 to 2.5 look and feel, and here you can see Fitbit application. And the big thing about it is having a fisheye effect, so you can see from the slide that it kind of improves a little bit the visibility, that the items that are on the edges of the screen, they scale down a bit. It is a power horse of all apps on Wear Compose, and you can only use Wear Compose for watch apps these days. So it was pretty much everywhere, because on Wear there is just a little bit, the screen size is very small, so everything has to be wrapped either in some sort of a list or a pager with a list. And the scaling effect was adapted to different screen sizes, and this one was built on top of LazyColumn. And things then, and I'm just a note, I'm using this fisheye effect, scaling effect, and transformation as a replacement between each other. And the big thing about this and the whole novelty was around this fisheye effect. You can see it is much better for the watches, because you can see a bit more with less amount of space. And the fisheye effect is the most complicated thing inside of all Wear lists, because everything is, imagine that you have a list and you're scrolling it, and all the positioning is done from top to bottom. But what happens if your top item that you are scrolling is scaling down while you're scrolling? So imagine that you've scrolled 10 pixels, and you would think that, everything scrolled 10 pixels, but no, because the top items scroll 10 pixels and shrink down 3 pixels, the total is 13 pixels, and it propagates to all other items, and the total effect is that you are just scrolling the screen and the content goes really, really fast. You are scrolling and everything is so much faster than your finger. And actually, to achieve this effect that visually the content follows your finger, it's a very, very complicated thing to do, whereas it sounds like such a basic thing for the list. But again, it is only perceivable thing. The top level, if you measure everything from the top item, it is fair calculation, but it's not how your eye perceives the UI and the content. And one thing to note about it is that item's position and its size and appearance depends on its position on the screen. So everything changes, the position and sizing of the next item changes because of the item before that. and why we started the new list. So for once, we needed to do material 3 expressive design, but there were so many things that we could do because Core Compose team provided us with a new level of lazy layout, and we could use lazy layout, and that's why we could do so much more, and we don't necessarily have to use lazy column as the backing technology for the scaling lazy column. Also, one other things that were enabled were animations and custom transformations per item, so you don't necessarily have to have the whole list adopt to the one certain style, and you have control of what animations you are using. And in that talk, I'm going to kind of, it's not necessarily this specific, but it is more like how you can build a foundational component for your company so that the whole company can start using it. And we're going to talk about strategic API design, driving adoption, collaboration, and a little bit of performance. Yeah, strategic API design. So I worked with the Core Compose team to figure out the way how we can present the API for TransformingLazyColumn. And after we did 4 rewrites, complete rewrites, and we were trying to figure out what is the essence of it, so what is the essence of transforming thing inside of the ware. And we figured that with all of these fancy effects and everything, it is just one simple thing, which is dynamic height. The height of the item depends on the position of the item on the screen. And we put it as a foundational component, and it is just pretty much single modifier, and the way how you can read the scroll progress from that modifier and from the graphics layer modifier. But thing to note here is that you have to have matching graphical effects. This one is pretty much, we are going to shrink down the item when we are placing it inside of the list. If the items are overlapping and what is the visual representation of the item, it is your business of the user. And if you want to have like a stacking thing of the list, you can achieve this by using TransformingLazyColumn. But if you want to have nice animation where the item's height is synchronized with the visual look of it, you would have to use graphics layer modifier and to read that scroll progress and synchronize the modifications that you are making. And I had this feedback from Andrei Kulikov, and he told me that this might be a part of the lazy column someday because it is so generic. But you don't have, we don't want all our users to just redo the whole transformations, figuring it's all out. So we did the API layering for where Compose that foundation is just scroll progress and transformed height, but on material we got a lot of stuff going on and a lot of indirections that you can do, and this enables use cases. So for one, you can start by just using remember transformation spec, and that is just remembers the default transformations for all the screen sizes that are supported. At the moment there are small and large, so it will interpolate all the graphical changes between those two specs. But if you are if you want to do some fancy effect, you can use the factory method from remember transformation spec, and you can, for example, hide the content completely before the boundary disappears. If you have extra screen, for example, you have a ultra watch with a screen size, you can add another screen size, third screen size. If you want to do some fancy rotations while your content is being displayed and while it is moved on the screen, you can do this by writing your own spec. Also, there is a level on the material level components themselves that called surface transformation, and that is the surface transformation kind of extracted away from the fact that it is in list, inside of the list, and you, with this API, you can make the transformations for your for your component when they are, for example, they are in a pager, or you can do something like when you kind of redo the whole painter and add something to your component. So it's kind of abstracted away from the list. They might be used in the placeholders API, where you just use surface transformation as a placeholder. And why we did so many layers? First, we did a magical approach, which you put material 3 components inside of the TLC. It all does it automatically, and we received the API, the pushback from API console that we should not do such magic, and the behavior should be opt-in rather than opt-out. And with that previous approach, it was really, really hard to do your own transformations, your own graphics layer modifiers, and etc., etc. And also, if you are not satisfied that transformations that are provided inside of the material layer, you can just remove the whole material level and just use the graphics layer plus transformed height and do it all by yourself. And in our notifications example and mocks, for example, some elements of the notification card were disappearing faster than the content. For example, the time text. When it collapses, the time text, the body of the message is not that needed, and that's why the content was faded away faster than the background. Yeah, and the big question was, when we're working on the API, is to add or not to add API. And for certain use cases, you are so pretty sure you need the API for that. For example, I was so blinded by the notifications use case, and there was one thing for the morphing that I thought absolutely has to be an API. And as we were working through it, and we already had API in one of the versions, I just figured it's just one client, and maybe Gmail is going to use it, but most probably not. And we are like, okay. I just before the API freeze, I removed that whole API feature set, made it a demo, and provided it as a demo instead. Because once you release the API, you need to support it for many, many years. And some of the API use cases we had to adapt. For example, there were many use cases from notifications from our SysUI and so on and so forth. And once our 1P app started integrating TransformingLazyColumn, they got a lot of questions. They started asking a lot of questions. How do we do that? How do we do that? And what we started doing is that we would just put that examples into our samples. And the next time, next client asks about it, we just point them to the right samples. Another thing that figured, it is a lot of boilerplate that you have to add to use the basic scenarios of TransformingLazyColumn. And TransformingLazyColumn done in the foundational level, so it stays there, and it's supposed to survive material 3, 4, 5. And we, as a response to that, we started doing responsive TransformingLazyColumn, which just sits on the material 3 layer. It is very opinionated and won't get probably to material 4, material 5. And when I was looking through a lot of the use cases, how it is used inside of the Google, I found that many clients of ours are using the flag to switch the whole appearance of the app from material 2 look to material 3 look. And most of them were doing some kind of bridging copy of our TransformingLazyColumn that was switching between ScalingLazyColumn to TransformingLazyColumn. And I found 3 to 4 rewrites of the whole complete thing. So if you provide your clients with something that you can support, internal clients, that could be great. Yeah, and some takeaways: be familiar but unique. So the TransformingLazyColumn, it is like almost the lazy column, but with one fancy modifier. And if you're not using that modifier or any transformations, you should be using LazyColumn. And design for evolution. to abstract the core components and what the core essence of the component and what is fancy things on top of that. And be prepared to change the design with the evolution and migration in mind and your client needs. Driving adoption and collaboration. So your awesome new component needs users more than anything. So for that, we kicked off the working with the SysUI components by just organizing the workshop, and I worked with the HDFI designers ahead of time to build the prototypes of the surfaces of SysUI components for notifications, QSS, launches, and when they came to the workshop, yes, it is not real SysUI, it is running on mocks, but you can see the effects and everything was there, so in their perspective, it's kind of, we can start building, using that. You can postpone developing or releasing some features that don't require your clients to change code for later, and having MVPs for unblocking the early integrations. For example, this bounce problem is one of the most complicated things of the TLC. What are the bounds of the list? Like when the items are shrinking down, when you are scrolling, what are the bounds? Because once you scroll and start to do over scroll, yes, your item moved 10 pixels, but the total move might be 15 pixels because of the scaling effect. But your requirement is to have exactly, for example, 30 pixels above as the content padding. And so to unblock the partners, the first version came with no bounds. You can literally scroll the list to infinity and you would see the empty screen. But at this point, it allowed them to start integrating, start building, using components. Then for the phase 2, the algorithm was not exactly correct thing, but for 7 months or so, it allowed our customers to use the components and build and do the screenshot tests, etc. And then just the final thing, we did an iterative approach where we did a little bit of gradient descent algorithm to figure out where the bounce and where the overscroll should stop and scroll backwards, and we were doing it all in the measurement phase. So we collaborated with a lot of SysUI, and we collaborated with a lot of 1P partners. It was great that we were correct figuring out the API, but there were sometimes that we were not correct, and we had to redo things on the API layer. But we have already had a lot of 1P apps who already were using that. So we came up with the plan to adopt this transformations API and to migrate the whole our 1P partners to using our new APIs ourselves. So for each partner, we first started it as just like exploring the code base, suggesting the one approach and saying, oh, we are going to do it that way, and sending them requests. And it didn't work quite well because of all of them. It's like, that is free, but that's not the way we want it to be. Maybe but it is free. But then we moved into a world where I would suggest them, for example, 3 ways of doing it. Okay, we explored your code base. There is this way, that way, and third way. How do you want us to proceed? They were very happy, and one team in New York was like, oh, are you going to do that for us? Like yourselves? Even though you think that you might know your component better and better ways how it can be integrated into 1P apps, it's at the end of the day, it is your client's code, and a little bit empathy was a great help. And then we worked with UX to enable them tuning in the whole system UI. just by using ADB configurations. So there was this problem that the designer was in New York, then SysUI was in California, and then I was in London, and every time that we would have to change and tweak some parameters for the transformations, we had to sync. And then our TL had a nice idea that we can just do ADB commands to tune in the whole SysUI. And we did exactly that, and our designers played with it for 2 weeks, and they were absolutely happy. They were like, that's amazing. We tuned it to perfection and did not require any engineering to be involved. At the end, they gave us one big file with all the parameters, everything. We just applied it, used it. It was a great experience. Yeah, as a takeaways to adoption-driven collaboration, it's like making it real. You all know these jokes about how you can draw an all from 3 circles and you are being presented with hello world app, but then you need to build a real app and it should look completely different from what you are seeing. Then some empathy with our client teams helped, and also working with UX and SysUI as a partners. And then you've heard a lot about the performance during the conference. So when Ware 6 was launching, there was a bold goal of being faster than Ware 5. So it's not like some glass-related UI framework that is making phones slower, and you have to pay. Oh, you want fancy glass-looking effects, or 2 hours of your or 2 hours of your phone life. And the watches are very small, tiny. It's like entry phone level phones from several years ago, if you want to think about it that way. And yeah, when we started doing TLC, the perception was, oh, there are so many visual effects, it's going to make it much slower. But some effects were so much cheaper, all these transformations with the fading, etc., etc. But some of them was so much slower, and until you measure, you just don't know. But for one SysUI, I wanted to bring some new visual effect for transmorphing so badly that I went to optimize their code, and I tried to use all best practices in their code. Measured, it got worse. Yeah, and until you have measurements, you cannot just assume blindly. And also, you never know how your component is misused in your client code, and there might be a lot of overhead by adding your component, and it is not exactly because of the way you wrote it. So we added a lot of tracing into TLC, and there was just a random thing when notifications got so much slower, and they were sending us perfected trace, but because we had it all in place, we were saying, oh, in fact, TLC is just as it was. According to that metrics, is just something else on top is slower. Yeah, and also we had this launch cycle. There is an internal monorepo inside of the Google that is called Google 3, and each time there is a release, there is a drop of Android X into Google 3, and this loop is very slow. It takes a lot of time, and we build, for some critical changes, we were building APKs of our clients, and it is very helpful when the main client is SysUI and you just build one APK and you install it and see it and just have a visual look. And then we did a performance tests that were mimicking our clients' use cases, and you could see that, okay, you can relate sales with the performance like numbers, and you can see effect over time that like the performance was good, something drop, and you can always correlate with the CL or pull request number. Yeah, takeaways, I just measure, and when you're doing the component, it is more like every millisecond matters because you never know how your clients are going to use it, and have traces. Yeah, and there was another talk on building modern expressive Wear OS app that you can see in the recording. Thank you. That's all for me.